Hey guys, it's Mr. Davis. In this video, we're going to talk about the Pythagorean Theorem. I'm going to teach you the Pythagorean Theorem, and we're going to do the most basic type of Pythagorean Theorem problem. Now, even though these problems definitely are easier with a calculator, you need to remember, the big hint for the day, you've got to write down your work. This is not something you just plug into a calculator. That's a terrible habit to develop, and that's where kids make mistakes. The kids that just type it in a calculator are the same kids that get it wrong. Ready? Let's get started. We're going to review the Pythagorean Theorem by looking at this problem and talking about it. Ready? This is a triangle. It's a special type of triangle called a right triangle. I know it's a right triangle because of this box right here. This is a way of writing 90 degrees. Because we're lazy in math, a box is faster than writing the 9 and the 0. So this is a right triangle. This side right here is worth 3. Because this side right here in red is connected to my box, it's a leg, L-E-G. This side down here is worth 4 that I just drew in red, and it's also connected to my box, so it's also known as a leg. My last side I'm drawing in blue. My last side is not connected to the box. It is called the hypotenuse. Hypotenuse. And that's a big long word. If you want to just think about hypo for right now, we can call it hypo for the next couple months. That's not going to ruin your life. It actually might make things a little easier for you. So, when I'm looking at the Pythagorean Theorem, here's the big idea. These two sides that are legs, my two leg sides, can be changed into squares. In fact, all of my Pythagorean Theorem problem can have squares as the side. So I'm going to draw some dotted line squares here. Now, I am not trying to make these squares perfect. In fact, down here, I'm just going to make it a rectangle. The idea of it being a square is what's important, not my picture. And up here, I've got a blue one. I'll make it a little bit more obvious that this is a blue one. Very cool. So the Pythagorean Theorem basically says that the area of the two small squares add up to be equal to the area of my big square. So the leg as a square plus the other leg as a square equals the hypotenuse as a square. So I did not have a number on my hypotenuse. See, the leg is worth 3, this leg is worth 4, this one is not known. So I'm going to label it as x. And now I'll zoom out and we can solve this problem. 3 as a square, so I need to find the area of that square, which will be 3 times 3. 3 times 3 equals 9. Oh, and this leg square is going to be 4 times 4. The area of that square is 4 times 4. 4 times 4 is 16. And my last one here, well, let's see, if I got 3 times 3 and 4 times 4, my last one would be x times x. And see, we don't really know what that is because x is a variable. But because of the Pythagorean Theorem, I know that the area of the two small squares adds up to be the area of the big square. So my two small squares have an area of 9 and 16. So I can add those together and get 9 plus 16, which is 25. So x times x equals 25. Super cool. Now, x times x can also be written as x to the power of 2, because there's two numbers multiplied to each other. So x to the power of 2 equals 25. And that helps us because we know the opposite of a power is a root. And not just any root, because that's a 2, it's a second root. That goes away, and I get x equals the second root of 25, which I can type in my calculator, and when I do, I get x equals plus or minus 5. Remember, second powers have two answers. Now, just because x could be plus or minus 5 from the algebra doesn't mean I'm actually going to use that minus, because there's no such thing as negative length. So my walkaway here is that my missing value, x, equals 5. That's the answer to this problem. Let's do a few more. Go ahead and see if you can solve this problem. And when you're done, hit play and I'll show you the answer. All right, here we go. Well, I've got 5 as a leg, 12 as a leg, because those sides are both connected to the box, which means my last side is my unknown, and it's an x, and it is my hypotenuse. Pythagorean theorem is I take the 2 legs and turn them into squares. So the area of this square right here would be 5 times 5. 5 times 5 is 25. The area of this square here would be 12 times 12. 12 times 12 equals 144. So my last side would be x times x, and it would equal the 2 smaller areas added together. 25 plus 144 is 169. X times x can be written as x to the power of 2 equals 169. Take the root on both sides, the second root, to get rid of the power of 2, and I get x equals plus or minus 13. Obviously, though, we can't have negative length, we can't have negative length, so I'm going to get rid of the negative answer and only keep my positive answer, and that missing side is worth 13. All right, try this problem. Hit pause, and then hit play when you're ready to check it. Here we go. The first thing I'm going to do is I'm going to mark my missing value, my x, and then let's go ahead and solve this problem. 6 times 6 is 36. 8 times 8 is 64. My last side would be x times x, and it's going to equal the 2 smaller areas added together. 36 plus 64 is 100. Now, x times x can be rewritten as x to the power of 2, and that equals 100. I'll take the root on both sides, the second root, to get rid of that power of 2, and I get x equals plus or minus 10. But of course, I can't use a negative 10 because this is a length, so my answer is going to be x equals positive 10. Go ahead and try this problem. When you're done, hit play. Alright, here we go. I'm going to mark in my missing side as x, and I'm going to find the area of my 2 small squares. Here's that first square, here's that second square. 9 times 9 is 81. 40 times 40 is, let's see, I need a calculator, because this is a little bit too hard for poor Mr. Davis to do in his head. It is 1,600. 1,600. First of all, did you see how fast that got big? Holy cow. Holy cow. And so, let's see, my last square, the square for my hypotenuse, is going to be x times x. And so, x times x is going to equal the area of my 2 small squares added together, which is 1,681. X times x is the same thing as saying x to the power of 2, and that equals 1,681. That's the opposite of the power of 2 is the root, so I'll take the second root of both sides, and I get x equals the second root of 1,681, which is plus or minus 41. I can't use minus 41 because this is length, so x equals positive 41 is my answer. So far, I've made sure to give you problems that have a pretty rational number as the answer. This next problem is going to have an ugly answer. It's going to have an irrational answer. Go ahead and give me the decimal for our missing side. Hit play when you're ready to check your answer. Okay, the first thing I'm going to do is I'm going to mark my missing side as x. I see that that missing side is a hypotenuse. So I know that the hypotenuse as a square equals the smaller 2 sides, the legs, as squares. So let's see. I need to make 5 a square. 5 times 5 is 25. I need to make 7 a square. 7 times 7 is 49. My hypotenuse is x, so x times x equals my smaller 2 squares added together. 25 plus 49 is going to be 74. X times x is the same thing as saying x to the power of 2, and that equals 74. Let's take the root on both sides, but not any root, a second root. And I'm going to give you the decimal. X equals a positive or minus, and I got a control hat, 2, arrow to the right, 74, and I get 8.60233 ... because it keeps going. It's one of those irrational decimals that never ends. And do I need the negative version? Nope, I do not need the negative version. So my answer is x equals 8.60233 ... And that's what we're going to use for right now as our answer. One last problem. Please find the value of our missing side. Hit play when you're ready to check your answer. Okay, my missing side is the hypotenuse, so it's x. And let's see, I know that the smaller two sides as squares, 4 times 4 is 16, 10 times 10 equals 100. The smaller two sides as squares will add together to make my bigger side, x times x, as a square. 16 plus 100 is 116. X times x is the same thing as saying x to the power of 2, so that equals 116. Let's take the root on both sides. The opposite of a power is a root. The opposite of the second power is the second root. And I get x equals plus or minus, because that's an even power. X equals the second root of 116, which is 10.7703 ... I have to put those dots there because this is an irrational number. The decimal keeps going. The calculator just doesn't tell me any more digits, but that doesn't mean the decimal stops there. I don't need my negative version. Whoops, that doesn't need to be there. I don't need the negative version, so that means my answer is x equals 10.7703 ... That's my answer. Good job, guys. I hope this is getting to be easy for you. From here, it does get more complicated, but once you've mastered this basic idea, the new complications won't throw you off. You can absolutely do it. I believe in you. Good job, guys.